Welcome back. This is another problem that's given some of you a real hard time. Now, again, if you have still not watched the video on given molality, given molality and density, how to find molarity, then I highly recommend you go watch that video first, at least to find out again what part of the problem you don't understand. Because if you understand that problem, this is exactly the opposite of that problem. Okay? All right, now let's read the question. Question reads, I have a bottle of sodium chloride solution. Its strength is 15% and its density is given. What is the molarity? As with any problem I've told you repeatedly, first go find out what is the question asks you to calculate. It asks you to calculate molarity. And what is given? It's given the density of the solution and it's given strength, which is essentially the mass percent. Okay, so and I have repeatedly told you, molarity is, unless you start writing units, most of this will make no sense. Okay, we know molarity is moles over liter, right? And in this case, we're not given molality, but we're given density and mass percent. So this is just another variation of that problem. Okay, so ultimately when you're finished with a problem, this is what your unit should be. And again, if you start writing a problem and write a bunch of numbers, then it's most likely what causes you that either a starting trouble or the progress issue, because you cannot move forward in the problem if you're not writing units to the respective numbers. Now let's tackle this 15%. Okay, if strength is 15% means you've got 15% of solute and 85% of solvent. They don't tell you ever the mass percent of a solvent. So mass percent is usually written for a solute. So you can figure out the mass percent of the solvent. And so this means if 1% is 1 gram, that means 15% corresponds to 15 grams of your sodium chloride, and 85% corresponds to 85 grams of your water, right? And the mass of the solution is 100 grams. This right here is the mass of the solution, right? Why do we need that? I'll tell you in just a second. Right? Now, think about the problem, okay? You may watch this video and write down everything I have written. But if your goal is, well, I'll remember everything he has written somehow, well, you may remember it today. But on a large scheme of things, how much do you realistically hope to remember? Let's say another month from now, when you have to remember everything else in the coursework, do you realistically think you can remember every single stroke that I have written on the screen? Probably not. So understand the concept. So we do know the mass of the solute here, which is 15 grams. So just by merely applying grams to moles using molar mass conversion, we can get the numerator. Let's do that. Why don't we do that? So 15 grams is the mass of my solute. So 1 over, and sodium chloride is 58, I believe. So 58 grams over 1 mole. Okay, so that means 15 over 58. .258 moles. Okay. Well, guess what? We already know the numerator. So our job is to somehow figure out this new denominator in this problem, and that's in liters, right? So again, I repeat, don't just write density. It is density of the solution. Okay? And density of the solution is mass of solution. You see, I'm not just writing a bunch of numbers or taking too many shortcuts. You could, once you get comfortable with the content, I still recommend that you always write out everything, right? So we know the density already. We know the mass of the solution. So we can just do a simple algebra to get the volume of the solution. And that would be in mils, which then you have to convert it to liters. Why? Because the density is in mils. So we know it's 0.89 grams over mils. That's the density. That's equal to mass of the solution is 100 grams. We just need to find the volume. So if you just do, just do algebra, V equals 100 grams over 0.89 grams over mils. And this will give you the answer in mils, which then you can convert it to liters. So So 100 over 0.89 is 112 mils. Now that's the volume. Now we do have the volume of the solution. This right here, folks, is the volume of the solution. Okay. But even though we had the right answer, it's not the answer we wanted because this is in liters. So that means 112 mils over 1, and there's 1,000 mils in a liter equals 0.112 liters. Guess what? Now we know the denominator. Now we can just go solve for the molarity, which is molarity equals moles over liters. So 0.258 moles over 1.112 liter. So 0.258 divided by 0.112, it's 2.3 molar. Or 2.30 moles per liter. Now, as I said, you cannot simply copy everything I have written, hoping that you understood. You may have, but here's what I want you to focus on is areas of difficulty, okay? Most of you are probably not writing the density in this form, okay? If you don't, you will never actually be able to proceed further in the problem unless you have actually comprehended the problem. If you don't write it, then chances are you don't know where to go, and you're just randomly multiplying numbers by molar masses just as a way to get to certain units you have in mind. Second is this concept right here, okay? Unless I tell you 15% corresponds to a certain gram, if the percentage appears by itself, that means 1% corresponds to 1 gram, and 15% is corresponding to the 15% of the solute. It's not the solvent. So 1% is 1 gram, 15% is 15 gram, 85% is 85 grams. The total always comes to be the mass of the solution. And so we know the mass of the solution. We just have to figure out the volume because we already know the density. Okay. Again, that all relates back to the very, very foundation. I'm going to put a star here. If you don't start writing what is given and how I'm going to express it in the correct units, chances are you may get it right once, you may memorize once. I'm telling you the bad news, it's just not going to help you get too far understanding this material. Okay, write the units. Have you noticed a place where I did not write units? Did I solve any part of the problem? Anywhere, everything I wrote had units in it. And that's a big part of solving chemistry problems, which involve a lot of math, because if you just leave out units, write 112 over 1,000, 15 over 58, chances are you don't even know where you're actually in the problem. You could spend 4 hours circling around, and after the 4-hour period, you realize I've done something for the last 4 hours and I'm still not solving the problem. Well, it tells me two things. First, you don't know what you're doing. That's kind of what, if you spend 4 hours for this problem, then chances are you don't know what you're doing. And the reason why you don't know what you're doing is because you're not writing any units, you're not following something systematically, okay? Just take cooking, for instance. When you learn something for the first time, you follow exactly how it's in the recipe. Only when you get comfortable doing it, you make changes to it, okay? You don't just go making changes. Or you just don't read 1.5 tablespoon, you just leave out the tablespoon and just put 1.5. Does it mean teaspoon, tablespoon, or cup, or ounce? You don't know that, all right? So just how much the units are important in a recipe that you use for cooking, when you solve a chemistry problem, units are just as much important, all right? So this is just an alternate way of finding molarity given mass percent and density. So you can calculate molarity given mass, given molality and density, or mass percent and density, or you could be given molarity, mass percent and density, and then you can find molality, or you could be given molarity and mass percent and find molality. I have done every single problem of every kind, and again, you also realize that in the lab, we've done enough practice on these concepts. So at this point, I'm going to stop this. This is how you solve this problem anyway. So that's the worked out solution for it. And I'm going to solve 1 or 2 more problems that again looks at this whole concept from a different vantage point. All right. So stay tuned.